Hello everyone, I am Dariusz Borowczak, Application Engineer Team Lead at LMI Technologies. In today's video, we will explore the built-in settings and parameters of Gocator 3D snapshot sensor to obtain the best data quality from shiny and reflective surfaces. In this session, I will be using a Gocator 3506 to scan a shiny and reflective casted and machined magnesium part. The Gocator 3506 can achieve a high VDI/VDE accuracy down to 12 micrometers, a scan volume of 30 by 45 by 25 millimeters, and a fast scan rate of 6 Hz. This sensor is widely used in various industries such as automotive, consumer electronics, or general factory automation due to its technological advantage and intuitive built-in GoPxL software. However, some challenging surfaces require the experience and awareness of the possible settings that can improve data quality by reducing surface and edge noise, especially when scanning a shiny and reflective object such as the one we are going to scan today. The very first step is to discover the sensor in your network and add it to your current GoPxL instance. First, we go to Discover tab. This tab shows that our Gocator 3506 sensor is available. By selecting this 3 dots icon, you will extend the menu and see the option to add as a new sensor. In pop-up window, you will be able to confirm and add the new sensor. The sensor is now ready for use as the status indicates connected. It's worth mentioning that all the settings I'm going to present are available on the Inspect Scan page of the Gocator GoPxL software, located in the main menu on the left side of the user interface. Before the first data acquisition, please make sure that you adjust the sensor position so that your scanned object is within the measurement range. I have done this already. When setting up the sensor, I always recommend enabling the acquire intensity by clicking on the checkbox. This function allows the sensor to map a 2D intensity image on top of the 3D data and use it for 2D data analysis. However, in this video we will be using the intensity data to check the influence of the set parameters. Now, let us take our first shot and acquire 3D data with default parameters. Please note that the sensor parameters are not set properly yet. As you can see, the data generated contains a lot of drops and reflections due to the non-relevant settings. This Gocator 3506 is set as default to 15,000 microsecond exposure time, which leads to overexpose of the image and results in a lot of data dropouts and reflections. This can be checked in the intensity image, or even better, in the image scan mode, which allows the user to check the raw data acquired by the sensor. After switching between different scan modes, please remember to trigger the sensor to acquire new data. The acquired image shows us a raw data used to generate 3D surface. As you can see, the data is overexposed in the way that the geometrical features such as edges, holes, engravings, and surfaces cannot be correctly defined. By clicking on this shooter icon, you can activate the functionality that will colorize your raw data depending on the brightness level, marking red when the pixels are overexposed and blue when they are underexposed. This feature is very useful for understanding how the projector light is reflecting back into the image and whether it might causing the reflections and or missing data. Please keep in mind that the dropouts can be caused equally by overexpose or underexpose of your image. Another useful feature implemented in the image scan mode is the ability to check if an external light source is affecting your data acquisition. In this case, you need to go to the exposure section and select projector off from the drop-down menu under video pattern type. By triggering the sensor without any projected light, you can check if an external light source will interrupt the data acquisition. However, in reality, this is not often the case because of optical hardware design. As an example, I can show you that with an unreasonable long exposure time, we will start to see a daylight interruption going through our laboratory windows. Great! You have just learned our basic built-in functions and settings, which will help in the future steps of setting up our sensor. Shall we move on and work on adjusting the exposure time? Let's go back to the surface scan mode. I always recommend start with setting the exposure time from the shortest to the longest and check the data quality along the way. This process will give you a good feeling at which point the data are underexposed and which overexposed. Start with 100 microseconds. As you can see, this data is underexposed for most of the surface. Nevertheless, the very shiny surface gives us a good response with this exposure time. Let's increase to 200 microseconds. The amount of the data is better, but we start to see the edge noise. After 200 microseconds, let's move on with finding best exposure by increasing the parameters and reviewing the data. Based on our experience, the cycle of increasing and decreasing the exposure time depends on the complexity of the scanned surface. The aim is simple: find the best exposure time. As we have defined it with the previous steps, the exposure time of 1500 microseconds gives us the best overall results. At this point, I would recommend trying and taking advantage of reduce occlusion function, which you can find in the scan mode section. When set to standard by default, in addition to stereo correlation, each camera independently triangulates the LED light pattern, which can improve performance on targets with complicated shapes that can cause occlusion. When high quality is selected, an enhanced algorithm is used to merge the images from each camera, reducing the seam where the images merge. When the reduce occlusion option is disabled, 3D data is acquired using only stereo correlation between two cameras, meaning that a point on the target must be visible in both cameras to produce a data point. As you can see, the high quality option helps us to generate more dense surface, but also reduce edge noise and smooths the data. In our example, we see that by using a single exposure time and reduce occlusion function, we are able to greatly improve the data quality. However, to help Gocator users solve the most challenging applications, our Gocator 3D snapshot sensor offers a multi-exposure functionality. Multi-exposure provides the ability to combine data from multiple exposures to create a single 3D scan. You can define up to 3 different exposure levels. Let's set the multi-exposure starting with 100 microseconds. The second exposure we will use at 200 microseconds, and the last one slightly longer, 1500 microseconds, to allow the sensor to generate data from surfaces that reflect lights differently. Perfect, we obtained very good data with a low level of missing points, reflections and edge noise. The last thing I would like to show you in today's video is an advanced feature called the interreflective engine. The GoPxL platform allows you to configure the data acquisition to suit different types of target material. The interreflective material option is useful for targets whose surface might show reflections from other surfaces in the scanned area. To enable the interreflective functionality, navigate to Advanced section and select Interreflective from the Material Type drop-down menu. What you will notice is that the setting will also adjust the projected pattern, as the data generation engine required a different pattern structure compared to the default diffuse engine. Data generated with this engine will have eliminated edge noise artifacts and produce the best data quality. The interreflective function with standard firmware consumes a lot of processing power. LMI Technologies offers a special firmware that optimizes the on-sensor performance of the interreflective scan engine. available for download from the LMI Download Center. This firmware results in the faster cycle times for challenging targets. We have successfully set the parameters of the Gocator 3506 to obtain very good data quality from challenging, shiny and reflective target. If you have any questions or would like to discuss your challenging application with our application engineering team, please do not hesitate to contact us via our web form.